Hello everyone, myself Pallavi Patil from Praveen Patil College of Diploma Engineering and Technology. In last video we saw the Unit 4 Part 2. In that we saw the line coding techniques and types. In this video we will learn the Unit 4 Part 3. Let's see what are the outcomes of this video. The learner will be able to understand amplitude shift key modulation, BPSK block diagram, PCM block diagram, delta modulation block diagram, comparison in PCM and DPCM and DM. Let's see the first amplitude shift key, that is ASK modulation technique. It is a type of amplitude modulation which represent the binary data in a form of various in the amplitude of signal. Any modulate signal has a high frequency carrier. The binary signal when ASK modulate gives a zero value for low input while it gives the carrier output for the high input. These are the figure for the ASK modulate waveform along with its input. To find the process obtaining this ASK modulate wave, let's learn. Simply, the ASK is a digital modulation technique in which the carrier will taken out one of the two value in the response to 0 and 1. Okay, the digital modeling message signal. Amplitude shift key is a simplest form of digital modulation. Here the carrier is a sine wave of the frequency. Simply, this is the ASK modulator. The ASK modulator block diagram is a uh, compromise the carrier signal generator. The barrier sequence from the message signal and the band limited filter. This is the following. This is the ASK modulator diagram. The next BPSK block diagram. This is a waveform. BPSK means is a binary phase shift key. This also called as a two-phase PSK or phase reversal key. In this technique, the sense wave carrier taken two-phase. In this phase, two-phase the reversal such as a 0 degree to 180 degree. The BSK is a digital information from the source may be a unipolar NRZ data which varies between the value 1 and 0. The digital signal from the information source is a unipolar NRZ signal. This is a diagram. BPSK block. This is a block diagram, and this is the output of the waveform. The digital signal from the information source is a unipolar NRZ signal which first convert into the bipolar signal. This signal acts as a modeling signal. The BPSK modulator is nothing but multiplier followed by the band pass filter. The multiplication of the BPSK output will be present with zero phase shift when the binary 0 is to be transmitted and when the digital input 0 is 0, then we will get the BPSK output with 180-degree phase shift as a showing. From the waveform analysis, we can conclude that when the binary 1 is to be sent, the carrier is transmitted with 0 phase shift, and the binary 0 is to be sent, then the carrier transmitted with 180-degree phase shift. This is a waveform of the BPSK block diagram. And the BPSK modulator. This is a block diagram. This is a the modulator BPSK done using the balance of the modulator, which multiply by the two signal is applying input for the zero binary input, and phase will be zero, and for the high input and phase reverse of the 180-degree. This is the BPSK block diagram. And next is a PCM block diagram. PCM block diagram is a simply is a PCM stand for the pulse code modulation, is a pulse code modulation technique. The modulation is a process of varying one or more parameters of carrier signal in accordance with the instance value of the message signal. The message signal is a signal which beginning transmitted for the communication, and carrier signal is a high frequency signal which has no data but it used for the long transmission. There are many modulation techniques which are classified according to types of modulation employed. Of all, the digital modulation technique use the PCM, that is a pulse code modulation. A signal is pulse code modulate is convert it analog information into binary sequence, that is a first and zeros. The output of PCM will be reassemble a binary sequence. The following figure show the example of the PCM output with respect to instant value of the given below. This is the diagram. PCM block. PCM block diagram. This is instead of pulse trend, PCM produce a series of number or digit, and hence this process is called as a digital. Each one of these digits through a binary code represent the approximate amplitude of the signal sample at that instant. In pulse code modulation, the message signal is represent sequence of code pulse. This message signal achieving by the representing the signal discrete from the both time and amplitude. This is the block diagram of the PCM. The next is a delta modulation block diagram. the the types of modulation, when this is the types of the modulation when the sampling when the sampling rate is the higher, and then which the step size after quantization is a smaller value, the delta, such a modulation is termed as a delta modulation. Simply, delta modulation is a specified from the DPCM technique, also view has a 1 bit DPCM scheme, has a sampling inverter, has a reduce the signal correlation will be higher. Delta modulation is a differentiate the pulse code modulation technique in which the different signal is encoded into the single bit. Delta modulation symbol is a provide the staircase approximation of the input sample signal when only one bit per sample transmitted. This one bit is sent by comparing the present sample value with the previous sample value and the result whether the amplitude is to be increased or decreased is transmitted. If the step is reduced, 0 is transmitted, and if the step is increased, then 1 is transmitted. This is a delta modulation block diagram. This is a delta modulation block diagram. The next, in this block diagram, DM is stand for the delta modulation technique. In details is described below. If the sampling interval, that is a TS, is a DPCM, is a reduce the consistency. If we sample is band limited signal at rate much faster than the sampling rate, is adjustment the sample should have the higher collection. This sample to sample amplitude difference will be usually be very small. The next, the difference between and comparison between the PCM, DPCM, DM, and ADP. These are the different between the different parameter also used in a comparison, the number of bit and level of step size, quantization error, and this distortion and transmission bandwidth, feedback and complexity. When we creating something, then he find a complexity of the implement. These are the different comparison point in a PCM, DPCM, DM, and ADM. Thank you, dear student. This is a Unit 4 Part 3 PPD. Next video, we will learn the remaining part of Unit 4. And student, you have any doubt regarding this video, Note down your queries, note down your problem. We will solve your doubts in upcoming online session video. Thank you.